Checking Addressing Modes with Context-Free Grammars, research by Hara S. Hamza, presented by Addie Hannon for CSC 250. Context-free grammars, or CFGs for short, have a variety of applications outside of theoretical computer science. Fun applications include hiding digital data and predicting the secondary structure of RNA. In this video, I will focus on CFGs as a tool for checking addressing mode types. You may be wondering what an addressing mode even is and why they matter. Before diving straight in, here is some background about compilation. In the case of a C program, the compilation process involves the preprocessor, compiler, assembler, and linker. The compiler itself has the role of generating assembly code from a modified source program. Recall that assembly code is low-level, human-readable code with a one-to-one correspondence with machine code. Here's a very simple C program. Even if you don't know the C language, wager a guess at the output of the program. If you said hello CSC 250, that's correct. Compiling that 6-line C program with the S flag gives us 39 lines of the underlying assembly code. In order to execute an operation on the central processing unit, CPU for short, you must apply an opcode, an address, and a mode. The opcode is the specific operation to be performed. Examples from the last slide include load, also called move, shift, and add operators. The address is to the operand of the instruction. The mode indicates the way in which the operand of an instruction is specified. In other words, the mode tells the computer how to modify the address field before the instruction is executed. In the code example, note that we're working with two address instructions. The % symbol is our mode and indicates that the operand value is stored in a register. For the shift instruction, note the use of a $sign. This is a different mode and instead indicates that we want to use the constant integer itself. In this case, 25. Zooming out from the specific lines of assembly, here's a table of a number of other addressing modes. Feel free to pause the video here, as I won't be going through each one. The gist is that addressing modes tell the computer how to calculate an effective address and reduce the number of bits required in the address field. They are important to assembly programmers, compiler writers, and computer architects. With that quick introduction to addressing modes out of the way, let's turn to a review of context-free grammars. Recall that they are given by a for-tuple, v, sigma, r, and s, where v is a set of variables, sigma a set of terminals, r a set of rules, and s is the start variable. The rules in R have the form a right arrow u, where a is a variable and u is composed of variables and terminals. The language of a given context-free grammar is the set of strings containing only terminals that can be derived using the rules from the start symbol. While not important to this application, also recall that the associated machine of context-free languages is the push-down automata. We are now ready to tie everything together. Here are some additional details about the specific paper I read. The proposed system includes two parts, checking the addressing mode with the CFG and implementing the addressing mode. For the purposes of this video, we will focus on the first part, as it uses a CFG. Here are the specific CFG outlined in the paper. In stage 4, notice how inst is a variable that is used as a placeholder for the various opcodes, and r is used as a placeholder for the various numbered registers. Likewise, in stage 2, each addressing mode is mapped to the corresponding structure. On the left, you can see a worked out example showing how to get from an instruction to the corresponding addressing mode type. First, notice how MOV is replaced with inst. Next, the comma is replaced by SC and the specific registers are replaced with R. Moving to stage 3, we replace inst R SC with const. Finally, we map const R with the register direct addressing mode. As a proof of concept, the paper shows a simple program that performs the addressing mode checking. On the right, you can see a few more examples of how the CFG is used to get from assembly code to the appropriate addressing mode or an error. A future extension of this research is to implement a more robust error detection system that can determine the type of error as well as suggest ways to fix it. Now for a little bit about me and why I chose this topic. I'm a sophomore engineering and computer science double major with interest in computer engineering, robotics, and software engineering. I was thus curious to explore applications of theoretical computer science to electrical engineering and/or computer architecture. The research paper I've discussed here was published by the Institute of Electrical and Electronics Engineers and mentioned computer architecture in the first line of the abstract. In summary, the result presented here was a system for using a context-free grammar to parse the addressing mode from an instruction written in assembly language. The specific goals of the research were to check addressing modes and generally provide a better understanding of the different types. I think the paper succeeded in demonstrating this potential use of CFG. Furthermore, through reading the research paper and preparing this video, I've gained a better understanding about the ways in which various aspects of computer science are applicable to one another. Specifically, this semester I was concurrently taking an introductory computer systems course at UMass. In that course, I was introduced to assembly language and low-level systems programming. For those curious, the course is similar to Smith's CSC 231. As I'm generally more interested in computer systems and theory, it was cool to explore a computer systems relevant application of theoretical computer science. In short, while I won't say this specific result is the most groundbreaking and exciting, studying it has been meaningful in rounding out my semester. In addition to the aforementioned research paper, I also consulted the following sources to better understand the paper's content. Finally, here are my image sources. Thank you so much for watching.